Today we are learning about how we could milk 10 million cows. Liam, take it away.
Thanks very much, Aoife. So I'll have to start by apologising to any farmers in the room. If you're here struggling with workloads, this isn't the talk for you. If you're a software engineer that wants to learn more about Elixir, then you're in the right place. Hi everyone, thanks so much for coming. My name's Liam, and I'm here today to talk about Elixir and GenServers, and hopefully try to milk 10 million cows. And if you haven't guessed by now, it's going to be virtual cows, not actual cows. I'm going to split this talk up into 3 parts. The first is going to be a bit of a history around Elixir and Erlang. The middle part is going to be how we kind of make the cow process. We're going to look at some code. There's going to be a bit of a multiplayer game where you can win this trophy. It says most cows milked at NIDC 2025, so good luck everyone for that. And then at the end of the talk, I will try to milk 10 million cows, virtual cows of course. So there's a lot to cover. I'm going to get straight into it with the history. So Elixir is relatively new, as you can see from this timeline. It was created, first introduced in 2012, but it has its origins with another language called Erlang, which was built in 1986. So Erlang was built by these 3 men, Joe Armstrong, Robert Verding, and Mike Williams. And it was built to solve the massive problems in the telecommunications industry, mainly telecom switching. So for any given telecom system, there could be thousands, tens of thousands, or hundreds of thousands of calls, all happening simultaneously. New connections being created, connections being dropped, connections failing. And there was no software system that existed that could deal with such a workload. And these systems needed to run 24/7. They could never stop for code updates. And there was just nothing that could really facilitate this kind of workflow. So that's why these 3 men invented Erlang. And Erlang solved this problem very well. And how did it solve it well? Well, 2 words: concurrent processes. So I'm going to describe this in kind of 2 elements, the process part and the concurrency part. So a process in Erlang is like its own isolated program. It has its own code, everything you might expect in a piece of code, like functions, parameters, branching, looping, that sort of stuff. But it has its own execution flow and its own memory. So then the concurrency part comes in whenever we have an application. So this kind of red dotted box describes an application. We have 2 processes running within. Each process has their own code, and they can communicate by passing messages. So process A has the capacity to send a message. Process B can receive it and process it in kind of like a FIFO queue. So using processes, we were able to map telecom switching to 2 processes, and we were able to deal with those workloads. That'll do for that bit. And this is like a typical Erlang or Elixir application. So it runs on something called the Beam virtual machine. So it was developed in the mid-90s, so kind of 8-9 years after Erlang, by Bjorn Gustavsson and Bogdan Hausman. This is the virtual machine that Erlang still runs on today, and Elixir runs on today as well. So in a typical Erlang or Elixir application, there will be many different processes, maybe thousands, maybe tens of thousands or millions. They'll all be running in isolation, all running concurrently, all passing messages between one another. The Beam virtual machine will have a scheduler, which is an OS thread. There'll be 1 per core, and the scheduler is responsible for giving the process's execution time. So the most basic way to think about it is a process will get some CPU time. The scheduler will put it to the back of a queue, give the next process some CPU time, and that way all the processes can run concurrently. Then in 1998, we got Erlang OTP. So this was whenever, I should have mentioned earlier, but Ericsson own Erlang and still maintain it now, but they open sourced it in 1998 with something called Erlang OTP. OTP stands for Open Telecom Platform. It's got nothing really to do with telecommunications, but it was just like a series of libraries and standards for building Erlang applications. Then in 2012, we got Elixir. It was created by this guy, Jose Valim, a very clever guy. And this is just kind of a modern day version of Erlang. Whenever people talk about Elixir and Erlang, they often talk about it interchangeably, and that's because at its core they are the same. You can write Erlang code in Elixir, and it'll still compile and run in an Elixir application. So that's pretty cool. So yeah, it's got like a Ruby-inspired syntax. The purpose of Elixir was just to bring Erlang into the modern age of software development. Oh yeah, I included this slide. This is from the Stack Overflow survey of this year. I'm not really sure how to read this graph, but there's a bit of info text up in the corner here, and it says that Elixir is one of the most admired languages. It comes in at third. In second is a language called Gleam. It's another functional programming language that compiles and runs on the Beam virtual machine, and those are second and third only to Rust, which is seems to be quite commonly the most adored language. So, yeah. Before we move on, I really want to credit this guy, Sassy Uric, for kind of giving me the backbone of the introduction. He explains processes and concurrency 10 times better than I can. This is a really incredible talk, so even if you're not inspired by mine, I'd recommend going and watching this one. It's really good. And that brings us to 2025. So why I'm standing up here talking about milking cows. So if you haven't guessed, yeah, we're going to use concurrent processes for our cows. And yeah, let's look at some Elixir code now. So I mentioned earlier the syntax is Ruby inspired. So here we've got a string greeting, and it's got the value hello assigned. And then I can write that to the console using io.puts. And I'm intentionally shying away from using the word variable because values in Elixir are immutable. Once a value is assigned in memory, it doesn't change. So it has all the types you might expect. It's got like strings, tuples, lists, but it's got a type that you maybe haven't seen before called an atom. So this is just like a constant whose value is itself. And this is the notation, colon with like a snake case name. Most code in Elixir is within functions, and then all functions run within modules. So if I want to call this move function, I would call the module name and the function name, cow.moo. And that's pretty much it. That's like a whistle-stop tour of what Elixir looks like. I'm not going to go into too much more detail. We will see some more code, but that's kind of Elixir. If you want to learn more, go and learn yourselves. So this is the cow module that I wrote. So in all the demos in the game we're going to see today, this is the code that's running behind the scenes. So this just outlines some basic cow behavior. We've got an eat function, a milk function, and a function to check if the cow's full. So as you can see, there's not really any process. There's no concurrency here. And that's right. There's not meant to be. So in this cow module, this is what we call a functional abstraction. So this just outlines the cow behavior. Then the process part comes in this module. So this is our cow server module. And you'll see there's just below the module name here, I've wrote use GenServer. And what the use keyword does is it injects this module with code from the GenServer module. And then GenServer is what really is unleashing the power of Beam. This allows us to start our cow processes. There's like a lot of boilerplate in there that we don't need to worry about because we're using this GenServer module. And this is what it looks like inside the GenServer. Like obviously there's a lot more complexity and a lot more lines of code in there, but fundamentally this is correct. This is what's going on. So it's like kind of like a typical server. You've got an infinite loop and you've got state. So the GenServer can receive messages and process those messages, and those messages can manipulate the state. So we're just like looping with this value. Yeah, we're processing messages, and we can handle those synchronously and asynchronously. I'll go into more detail about that in a bit. And then just while we're here, some people say, Elixir is a functional programming language. It has a lot of the attributes of a functional programming language, but it's not purely functional, and it's because of things like this. So if you've got a GenServer and you've got state, the state is mutable, so it's not purely functional anymore. So yeah, that's why people say Elixir isn't purely functional. So just going to take a look back at our server module now. So we had that init function, and like we said earlier, we can use that to start our cow processes. We just use genserver.start, the module name, and any kind of initial arguments. As well, I've extended the server module to have a handle call function. So this code is running inside of our cow process. So if another process knows about our cow process, it can send a message, a call message, to check if the cow is full, and the cow will reply if it's full or not. And then we can also have casts. This is like an asynchronous type. So this will also run inside the cow process. So if you have a process that knows about our cow process, it can cast a milk message, and it won't return anything. So with all that in mind, we can start our cow processes. So this is just a for loop with some cow names, and then we're using our GenServer.start instruction from before, and that'll start 3 cow processes, cow 1, cow 2, and cow 3. You can see they all start eating at the same time. Sorry, I should have said I've amended the code slightly so that whenever the cow processes start, they'll eat until they're full. So they'll start at 0, and then they'll all finish at 4 at the same time, or appear to finish at the same time. It doesn't wait for one of the cow processes to finish before the other cow starts. That's because all these cow processes are running concurrently. So what happens if I intentionally add an exception into the code? So here, this is the eat function, and I've amended it just so it would raise an error. So at the moment, if I ran this, the whole application would topple. And I don't want that to happen because it should be an isolated process. It should fail in isolation. To achieve that, I'll add a supervisor. So this is I'll not go into too much detail about it, but just the bits in the red here are the most important bits. So I've got a list of names at the top, and then I'm starting my cow servers, starting 4, and then the strategy here is 1 for 1. So there's a few different types of strategies, but I'm just going to look at 1 for 1 for today. So if a cow process fails, then another one will start in its place. So if I run the application again, with the exception in the code, you'll see that it wasn't exactly cow 4 failing, but cow 2 throws an exception. That process fails, but you can see the other processes, they'll continue to run, and then cow 2, because it failed, it'll start again at 0, and the other processes continue. So yeah, that's pretty much it. Like, this is all the code for our cow process, and this is kind of the code that I've used in all the demos I'm about to show you and the game we're about to play. So you can see there's really not a lot of code here, but there's quite a lot of power behind it. So we've got our functional abstraction and our server module. So we're going to play the game very soon, where you're going to get the chance to win the trophy, but I'll just kind of touch on how it was built. So it was built purely using Elixir. It was used with this. This is Elixir's logo. This is Phoenix's logo. So Phoenix is a very popular web framework for Elixir. Then also LiveView, which allows updates from updates from server to client over WebSockets. And then I've leaned very heavily on the presence module. So presence does exactly what it says in the tin. If you're viewing a page, it'll track who's there. So I've used that to store the usernames and the scores. So just a little bit about the game. It's kind of like a multiplayer whack-a-mole. So if a cow is enabled, you can tap it and it'll add 1 to your score. If it's disabled, it means someone else has already milked it. So the cow will be disabled for like 5 seconds after it's been milked. And yeah, whoever milks the most cows will win the trophy. So I don't know why, but it's not working on the Wi-Fi here. It's this like content filter. But it is a trusted website, and plus I'm not storing anything. Everything's all in processes, all in memory. So yeah, if you just want to scan the QR code here, and I'll start it from my phone actually. So yeah, if you've got a hotspot, that would be preferable because it doesn't really work on the Wi-Fi. Oh yeah, and you can set a nickname. That would be handy for former Chris. Yeah, I'll just give people like 20 more seconds. Old MacDonald, ultimate cow farmer. Very creative. All right, is everyone ready to go? So in a second I'll turn on the cows and then you can just start tapping like mad. Yeah. All right. Oh, something went wrong. Oh, it's the Wi-Fi. All right. 3, 2, 1. Go. Kevin's off to a strong start. Farmer Ross in a close second. Oh, Farmer Ross is flying. Oh, it's tight at the top with Farmer Ross and Farmer James. Kevin's in a close third. He's going to give it 30 more seconds. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Big round of applause for Farmer Ross. You? One-of-a-kind trophy. Yeah, you're welcome. Yeah, so I've actually only tested that with 4 users before, so it's pretty incredible that it stood up with, I don't know, 20, 30 users there. So thanks very much, everyone, for taking part. I'll just go back to our slides now. So that was 50 cows with 30 farmers. How are we going to do it with 10 million cows and only 1 farmer? Well, very sorry to tell you this, but I submitted this talk before I wrote the application. And it doesn't work on my laptop with 10 million processes. But we're going to try it with 1 million. So this is my command line here. I'm just going to, right, if you look at IEX here, this pretty much starts like Elixir's REPL. Then I'm going to paste in this code to kind of batch start 1 million processes. Not that. So see how quickly we're starting. We're getting like tens of thousands of processes already. The cows are eating and they get to milk level 1. I've kind of capped this out at milk level 1 just because I don't want to sit and watch 1 million cows eat 10 pieces of grass. And then to milk the cows, it's just going to be this line here. So it's just a for loop from 1 to 1 million. These are our cow IDs, just like a cow and then a number. And then I'm just going to pass it the milk message. And this is all we need to milk 1 million cows. So if I ran this 10 times, it would be 1 million, or 10 million, but I'm not going to do that. It's going to be quite boring for just to watch all these processes run. So yeah, we just got to 1 million. So there's 1 million there. So of course these are running concurrently, so if one finishes first, then yeah, it's not running in order. And then I'm going to pass the, nope. This is the for loop with the milk call. And that's it, they've been milked and they've started eating again. So yeah, that's how you milk 1 million cows. If you want to see me milk 10 million, donate some RAM. So yeah, that's really about it. Got some closing remarks here. I'd like to thank Jose Valim, the creator of Elixir, for giving us such a beautiful language. I'd like to thank Sam Montgomery, my software tester. He helped me test this during the week. Also Russell for sharing the Sassy UX talk with me. It really helped kind of inspire this one and give it a bit of backbone. And Aoife, our room MC, who's also my girlfriend, for helping me write the talk last night. And yeah, everyone responsible for making the conference happen. It's a really good conference. I look forward to it every year. And yeah, and thanks everybody for coming. So if you want to know the real... Oh, sorry. So to answer the question, how do you milk 10 million cows? Use Elixir and have a lot of RAM. So, thank you.
Does anyone have any questions for Liam?
I have one. So, Elixir ecosystem might not be as full-fledged as, for example, if you're doing a JavaScript ecosystem also. So, a JavaScript, for example, it would be very easy to say, okay, I have my front end in JavaScript, I have my back end in Node, and Node has native AWS SDKs to go and actually hit stuff.
what would you do on the back end if you had the front end in Elixir so that you could actually get this stuff out connected to proper cloud services, for example, AWS SDK? Do you have a preferred language? Is there stuff that works well with an Elixir front end?
So I would write the full thing in Elixir, back end and all.
Okay.
So yeah, Elixir does have that capability. It ships with connection with Postgres.
All right.
So it's built to run with Postgres databases. So yeah, there are many web apps that exist, like the company I work for, Enzi. We have a software product that's built entirely in Elixir, front and back. And we just kind of Dockerize that and run it in ECS, on ECS and AWS. So it is possible. So, I mean, you're asking me who's talking about Elixir, how I would build backends, so I would obviously pick Elixir. So, yeah.
No, very good.
Thanks for the question. Yeah.
Hello, my name's Chris. Thank you very much. Lovely to see an Elixir talk. I've waited a long time. I'm just going to answer this guy's question as well. The Elixir ecosystem is perhaps the most sophisticated, given its origin, 2012, but given its history in the Erlang virtual machine, in terms of building full stack in its real terms. You can go from embedded, so there's a project called Nerves, which lets you build embedded Elixir. You can build all your Elixir backend in terms of data processing, machine learning now, they're supporting that. And the front end you can do in Phoenix, which you mentioned, which is a full stack, server-side rendered, real-time, all the tooling you could possibly dream of having to make your life easy, testable, and all the other benefits. So it was really just a thank you. And I've watched that video time and time again, the Sasha Urich one, and I fully back for everyone to watch it. If you're interested in building solid, real-time systems, Elixir is the way to go. Why aren't more people doing it? I don't know.
Yeah,
But
thank you. Just to add to that.
thank you.
Yeah, there's a massive Elixir community. We have conferences throughout the year, Beam conferences, Elixir conferences. I think there's going to be a Gleam conference soon. So there is a fantastic ecosystem and a massive
Community is super friendly.
massive
Yeah,
community of
so
people
go for
contributing
it.
to the language.
Jose will answer a question for you. No
Yeah,
problem.
you can email.
Yeah.
So and this is our Belfast community. So we're having a meetup next week or the week after. So if you want to scan the QR code and join the Discord, it's probably the best way to keep up to date with any updates on that. So.
Any more questions?
So you were saying about how you couldn't run the 10 million on your machine. What is the kind of resource usage like with Elixir? Like you ran 1 million processes there and it was running very, very fast without any problems. Is it very intensive, not very intensive? What's it like running at that kind of scale?
So every process is kind of a few kilobytes. So you, or like 50 or 60 kilobytes. I'm asking Russell, he's an expert. So yeah, that kind of scales up to as much RAM as you have. And then Beam, the virtual machine, imposes a limit of about 130 million processes. So yeah, if you have enough hardware, you can scale it up very high. So we could milk, if we had a supercomputer, we could milk 130 million cows instead of just one. Thanks.
Anyone else? It's time for lunch now, so enjoy the rest of the conference.
Yeah, thank you.